All right, welcome to Analytics in a Day. We're excited to show you how analytics can transform your business, and more importantly, what concepts you must understand to do more with data. So let's get started. In this workshop, we'll cover the breadth of cloud analytics capabilities with Azure Synapse Analytics. We'll teach you how to create an analytics pipeline that goes from data ingestion to business intelligence, empower self-service, and enable a truly data-driven culture in your business. As you can see from the agenda, this is a fast-paced workshop, beginning with a great deal of information about what Synapse can do currently and the direction it's headed. We will break this down by discussing the heart of analytics, followed by optimizing analytics with Azure Synapse, and we will finish up with the instruction and discussion portion of the workshop with insights for all with Power BI and Azure Synapse. We'll have a short 15-minute break followed by the hands-on labs. In the labs, we'll walk you through a hands-on training showing you how to get started on your own cloud analytics journey. As Alexis said earlier, the two speakers that you will be interacting with today are Jim Arnold, who is going to be leading the hands-on interactive sessions, and myself, Mike Sims. I'm the Practice Director of Data Analytics for Columbus Global. Here's all of our information should you choose to get a hold of us. We'll start off with the idea of how we're all in the data business and how critical data warehouses are. In section 2, we'll dive into how data warehouses and data lakes must meet to give us easy access to vast amounts of information. Then we'll begin to move into how business intelligence merges from that sea of data. In section 4, we'll touch on the advantages that cloud-based services bring to analytics. Finally, we'll explore Azure Synapse Analytics, a platform that provides a limitless analytics service with unmatched time to insight. Let's begin by talking about how a data warehouse is a fundamental component for getting the most out of your data. We all know that the world of technology moves fast. New products come to market at alarming speeds, and there are more and more sophisticated ways to capture and manage the ever-increasing amount and variety of data. So you might think it's surprising to hear that data warehouses are as relevant today as they were when they originated 30 years ago. Yes, this is true, but it's only the case because the data warehouse has modernized over time and is a distant relative of the data warehouse architecture from 1988. Let's talk about how the world of data has changed. First, all businesses are data businesses. From the corner store with online accounting and stock keeping to the largest internet retailers, we all run on data. And an enterprise that does not manage, govern, and secure its data will simply not survive in the new economy. It's one thing to gather and manage data, but it's another to make decisions based on it. This is where analytics comes in. Without analytics, data doesn't serve any role. Dashboards and reports support awareness of the current state of the business. BI and visualization strengthen the role of knowledge workers with informed insight. And augmented intelligence can discover information and patterns that even experts may overlook. Analytics are important, but it's increasingly evident that not all analytics are equal. Businesses can do more and more complex analytics for better, faster, and more automated insights. Data science enables automated insight with a depth and scale beyond the abilities of human analysts. Even small businesses today need scalable analytics of social media, digital interactions, and markets. Increasingly, machine learning and artificial intelligence drive autonomous processes and decisions for smart organizations. Now let's describe how a data warehouse serves a business through this simple architectural diagram. The modern data warehouse sits at the heart of enterprise analytics as a source of sanctioned data, as a system of record, and as a hub serving models for reporting, business intelligence, and data science. As an enterprise system of record for business purposes, the data warehouse is mostly built over line of business data sources. Whether that data is unstructured, structured, or semi-structured, the modern data warehouse can handle it. Other, more volatile sources are often used for data science or ad hoc analysis. For the data warehouse, Azure Data Factory schedules and orchestrates data transformations and bulk loads. Meanwhile, Azure Databricks performs transformations specifically for data science and also builds and executes models. Scores from these models may be loaded into the data warehouse to integrate these insights with enterprise applications and reports. Azure Data Lake may be used to store raw data in high volume for later use, along with staging transformed data from Azure Databricks. Azure Synapse Analytics provides high-performance, highly scalable data storage for enterprise models with outstanding security, governance, and manageability. Power BI consumes sanctioned enterprise data from the data warehouse for reporting and analytics, but may also use data from the data lake for ad hoc analysis and integrating with data science. Many business services, including line of business applications, consume data from the data warehouse as an authoritative, governed source of enterprise knowledge. Add Azure Machine Learning and you have a complete solution for cloud analytics. Microsoft has brought together data ingestion, big data, and data warehousing into a single unified service, Azure Synapse Analytics. Not only are these critical parts fully integrated and managed, but there is also deep native integration with Azure Machine Learning and Power BI. Finally, an end-to-end analytics platform that brings the critical functions of a data warehouse to be in the same environment as other data tasks. Now let's take a look at data warehouses and data lakes in the different worlds of data science and business analytics. Increasingly, analytics and AI have become a hot topic for businesses. But truly unleashing the potential of data with these technologies has proven challenging to leadership. Many businesses report difficulty deriving deep insight from data. Half of those who reported those difficulties also described disparate data sources preventing a holistic view. The approach to data lakes and data warehouses differs in a couple of key areas. Data lakes lend themselves to massive, semi-structured sets of data that allow for fast exploration and experimentation. This is not without its downsides. The clean data nature of data warehouses provide greater security and privacy and dependable performance with structured and relational data. However, both of these systems have important business value. To truly capitalize on data, businesses must invest in both distinct approaches. Security is paramount to businesses in our modern world. All businesses should have access to enterprise-grade security features, and more recently are mandated to have those robust measures in place. Meeting these requirements without an intelligent solution can create a significant management challenge. Allowing for open data exploration and experimentation while remaining stable, performant, and most of all secure is challenging when you don't have a clear view of the data in play. Controlling access to data in the first place can present its own challenges, let alone providing trusted users a streamlined authentication process. Providing quick and dependable service to users is tricky as well. Some requests are intensive yet predictable, where others are unscheduled and unique. On top of this, high priority service for C-suite stakeholders must be ever available. Flexing more muscle is always a solution to manage diverse workloads, but it's not without its drawbacks, namely the costs. And even beyond cost, bringing up these extra resources takes time and operating overhead. And finally, interacting with different formats can be cumbersome. Data scientists need the ability to query varied types of data with as little special handling as possible. Additionally, developers need set version control, consistent integration and deployment, and the ability to perform various testing scenarios. Azure Synapse Analytics brings together solutions that address both approaches of data lakes and data warehouses in a service that provides limitless analytics. It's quick and easy to configure, allows for fast exploration while ensuring enterprise-level security and privacy with the performance necessary to meet any scale of demand. We've talked about key elements in a modern data warehouse. Now let's dive into why it's important for business intelligence and what you need to do to derive intelligence from data. Understanding your data is only one piece of the puzzle in today's world. Being able to articulate your data's insights to your organization is where real value is found. Increasingly, decision makers reach beyond traditional reports and dashboards to engage with new sources and tools, big data, machine learning, and even AI. In this environment, being able to define and work with data-driven processes is essential. Data literacy has become more than just a useful individual skill, it is a shared organizational practice. When shared data literacy can be combined with self-service tools, individuals become empowered, teams become tighter, and organizations become stronger. Business users today are tech smart and expect tools and services that work the way they work. Just like bring your own device, users expect to use self-service analytics tools to build their own dashboards and visualizations. In an enterprise with self-service analytics, IT cannot expect to control or constrain every aspect of knowledge work, but they can provision data and services while monitoring usage and security. Self-service business intelligence puts data governance in the hands of all users. IT's new role is to provide well-managed tools and services to support effective best practices, even if they cannot guarantee the results. Services include curated data for business users to consume for BI and analytics. Platforms include data warehouses and data lakes with data science tools and self-service analytics. New business capabilities are enabled not by data alone, but by data models that describe concepts, relationships, rules, and standards. Enterprise models consolidate data from many systems and act as a centralized source for analysis. Business intelligence models use enterprise models but focus on a single subject area in more detail. And machine learning models are developed from raw sources and are often experimental and require specialty skills for production use. Now we'll revisit the different data models and talk through why they still matter if businesses are tech smart and data literate. First, for consistency. There are numerous business processes that should be built once and shared as a corporate standard, such as defining product catalogs, staff hierarchies, and client organization IDs. Next, for governance. Certain data sets, such as customer information or financials, need security and privacy controls, which may be complex and dynamic. And finally, for efficiency. If models already exist in the data warehouse, there is no need to repeat the work of design, preparing and loading data, or securing the model. Enterprise models are clearly important, but you can't get by with them alone. Let's now talk about how business intelligence models play a role. Why do users need them? First off, for flexibility. There are numerous data sets that are temporary, external, or ad hoc, and unlikely to be consolidated in a data warehouse. In these cases, business intelligence models are useful. For example, planning and monitoring a short-term campaign or modeling a budget for a departmental project. Finally, for efficiency, tech smart business users have a fresh and innovative idea that they need to explore with agility. The process of building centralized models to support all these initiatives is too cumbersome, but successful and widely adopted business intelligence models may be refactored into the data warehouse for future enterprise use. Enterprise models are clearly important, but you can't get by with them alone. Let's talk about how business intelligence models play a role. Why do users need them? For integration, simply the steps to wrangle multiple data types from multiple sources, including streaming, transactional, and business data. Use a code-free visual environment to easily connect data to sources and ingest, transform and place data in the data lake. Machine learning models can be created and made available within the analytics platform, making the results easier for people in the business to utilize them. The days of the citizen data scientist are upon us. For enterprise data scientists, Synapse allows enterprise data scientists to build proof of concept in minutes and easily create or adjust end-to-end solutions. Provision resources as needed or simply query existing resources on demand across massive amounts of data. They will work with the language of their choice, whether it's T-SQL, R, Python, Scala, .NET, Spark SQL, or any of the others that are out there. So we've talked about key elements to a modern data warehouse, but why should it be in the cloud? The cloud enables projects that are easier to start and easier to scale. Enterprise resource planning, customer relationship management, and operational applications are increasingly cloud native. Collaboration platforms and file sharing have been transformed by the cloud's flexibility and scale. Even when governance requires on-premises data management, modern businesses tend to be hybrid. Cloud-based data warehousing services provide layers of protection and built-in security and compliance tools. In the data warehouse itself, you expect encryption, sensitive data classification, and row and column-based security. But you also need the services such as threat detection and monitoring, virtual networks, and integrated ID management. Resilience and availability are not just good objectives, but vital security features for global, always-on services. Geo-replication, point-in-time restore, and the highest availability come with the cloud. Cloud-based data warehouses eliminate the need for large CapEx investments. Deploying your data warehouse in the cloud is faster, easier, and more flexible than a traditional solution without the high hardware and infrastructure costs. Iterating designs and handling diverse data is far more efficient than for an on-premises solution. World-class performance is available to all users as Azure Synapse Analytics optimizes analytic and operational workloads with the elastic scaling. As the volume and variety of data continually expands, modern cloud-based data warehouses can serve as the home for all data. Enterprise ETL, or self-service data wrangling, both are efficiently handled with no need to juggle processing schedules. Deliver enterprise-wide reports and enable ad hoc data discovery with an endless variety of visualization or data science tools. Power BI is the market-leading platform and offers incredible capabilities on Azure Synapse Analytics, the highest performance cloud data warehouse. Data warehouse query performance is no longer a matter just for IT. Today's leading tools like Power BI can analyze and visualize large volumes of data. Self-service users' queries are often exploratory and ad hoc, not scheduled. Power BI users wishing to analyze real-time or unstructured data need a scalable platform that can be queried easily with familiar syntax and connectivity. Azure Synapse Analytics delivers insights from all your data across data warehouses and big data analytics systems with blazing speed. Data professionals can query both relational and non-relational data at petabyte scale using the familiar SQL language. For mission-critical workloads, they can easily optimize the performance of all queries with intelligent workload management, workload isolation, and limitless concurrency. Azure Machine Learning augments your analytics capabilities and business insight with quick build-out and deployment. Empower developers and data scientists with a wide variety of productive experiences for building, training, and deploying machine learning models faster. Accelerate time to market and foster team collaboration with industry-leading ML ops, DevOps for machine learning. Now we'll wrap up this overview session with some final thoughts. Azure Synapse Analytics brings together multiple data sources, unstructured and structured data from on-premises, the cloud, devices, and line of business. It allows the integration management, monitoring, and securing of these data sets under a unified experience using familiar systems like SQL and Apache Spark. Natural connections with Power BI and Azure Machine Learning empower business users to make informed decisions at a much faster pace. Bring data teams together and enable them to seamlessly and securely collaborate, share, and analyze data. As data integration, data warehousing, and big data analytics can all be done from a single pane of glass, businesses can break down organizational silos that stagnate time to insight. Manage, secure, and analyze all types of data. A single service can query structured or semi-structured data with your data warehousing resources, and also quickly execute a serverless query over unstructured data from your data lake. Enable your data professionals to build end-to-end analytics solutions without having to stitch a multitude of services together. Bring all the existing skills across your business together to accomplish more with your data. With the deeply integrated Apache Spark and SQL engines in Azure Synapse, data professionals who prefer familiar SQL can seamlessly collaborate with those who prefer Spark and vice versa. For instance, those familiar or who prefer SQL can query Spark tables using the T-SQL language. And data engineers or data scientists who prefer languages such as Python, Scala, Spark SQL, or C# can transform data, train models, and create proofs of concept in the same service that houses data pipelines, data lakes, and data warehouses. It's a mistake to think that new technologies such as big data, self-service, BI, and data science have somehow superseded established technologies such as data warehouses. In fact, Microsoft's Azure Synapse Analytics, a modern data warehouse with advanced architecture, security, and manageability, is more relevant than ever. This is especially true when provisioning data for self-service, as regulations worldwide demand greater governance, even while businesses demand greater autonomy. All right, so let's dig into specifics around how Azure Synapse Analytics works. Azure Synapse Analytics is a limitless analytics service with unmatched time to insight that delivers insights from all your data across data warehouses and big data analytics systems with blazing speed. It truly enables next-level analytics. Simply put, Azure Synapse is Azure SQL Data Warehouse evolved. We have taken the same industry-leading data warehouse and elevated it to a whole new level of performance and capabilities and backed it with a cloud platform you can trust and industry-leading compliance. Not only is Azure Synapse Analytics able to provide petabyte-scale analytics with quick time to insight, but it does so with the best price performance in the industry. Azure Synapse Analytics is 14 times faster than other cloud providers, exceeding Amazon Redshift, Snowflake, and Google BigQuery. Let's look at some of the customers who have taken advantage of Azure Analytics and reaped the benefits. Each of these stories highlights a unique benefit they received. ABI's case highlights the performance enhancements they received due to data consolidation. Newell noticed significant cost savings due to efficiencies gained by moving to the cloud. And Walgreens used insights by building predictive models on their data to best manage their inventory while remaining scalable. All the customers we just mentioned use cloud scale analytics to achieve their goals. We have customers who leverage our modern data warehouse track to ingest and analyze varied data sources, as well as customers performing fraud detection analysis. Many customers are looking to gather insights on mobile devices in real time. As we talk through these use cases from the customers, notice that at the core, all of these examples is Azure Synapse Analytics. The reason, as we touched on before, is because Azure Synapse Analytics brings together three domains of a modern data warehouse. Varied data sources can be ingested, transformed, modeled, and served all through one powerful service. Azure Synapse is a limitless analytics service that brings together enterprise data warehousing and big data analytics. It gives you the freedom to query data on your terms, using either serverless on-demand or provisioned resources at scale. Azure Synapse brings these two worlds together in a unified experience to ingest, prepare, manage, and serve data for immediate BI and machine learning needs. We have taken the same industry-leading data warehouse to a whole new level of performance and capabilities. Businesses can continue running their existing data warehouse workloads in production today with Azure Synapse and will automatically benefit from the new capabilities that are in preview. Businesses can put their data to work much more quickly, productively, and securely, pulling together insights from all sources, data warehouses, and big data analytics systems. Azure Synapse has four main components. Synapse SQL, which is a complete T-SQL-based analytics, is currently generally available. You can utilize SQL Pool, which is pay per DWU provisioned, or data warehousing unit provisioned, and SQL On Demand, and that is paid by the terabyte, and that's currently in preview. Apache Spark for Synapse, which is deeply integrated Apache Spark, is also in preview. Synapse Pipelines, which is a hybrid data ingestion based on Data Factory, and Synapse Studio, which is a unified user experience, which we are going to be showing you today. Both of those features are also in preview, but you can utilize them in that preview state. Synapse SQL is a distributed query system that enables enterprises to implement data warehousing and data virtualization scenarios using standard T-SQL experiences familiar to data engineers. It also offers both serverless and provisioned resources models. Apache Spark for Synapse deeply and seamlessly integrates Apache Spark, the most popular open source big data engine used for data preparation, data engineering, ETL, and machine learning. A simplified resource model frees you from having to worry about managing clusters while allowing for fast Spark startup and aggressive auto-scaling. Synapse Pipelines comes built in, using the same data integration engine and experiences as Azure Data Factory, allowing you to create rich data pipelines without using a separate orchestration engine. It even enables code-free ETL with data flow activities. Synapse Studio is the web-native experience that ties everything together for data engineers, allowing them to do every task needed to build a complete solution all in one location. Let's take a deeper look at the setup of Azure Synapse. It's designed for analytics workloads, including artificial intelligence, machine learning, IoT, intelligent apps, and business intelligence at any scale. Azure Synapse Studio provides a unified workspace for data prep, data management, data warehousing, big data, and AI tasks. It's a SaaS developer experience for code-free and code-first. The platform is suited for multiple languages for compatibility with different analytics workloads. Plus, there are integrated analytics runtimes available, provisioned and serverless, including Synapse SQL, offering T-SQL for batch, streaming, and interactive processing, as well as Synapse Spark for big data processing with Python, Scala, R, and .NET. Integrated platform services enable management, security, monitoring, and metastore. And all of this is data lake integrated and common data model aware. And because it's on Azure, Synapse integrates with other Azure services such as Data Catalog, Data Lake Storage, Data Share, Databricks, HD Insight, Machine Learning, Power BI, and third-party applications. To recap, components like Synapse SQL, Apache Spark for Synapse, Synapse Pipelines, and Synapse Studio make Azure Synapse Analytics a unified end-to-end analytics solution. Synapse Studio is a web-native experience that ties everything together for data engineers, allowing them to, in one location, to do everything they need to build a complete solution. In Synapse Studio, you can build an end-to-end analytics solution. In one place, you can ingest, explore, prepare, orchestrate, and visualize your data. Industry-leading productivity for data engineers writing SQL or Spark code, authoring, debugging, and performance optimization, and integrate with enterprise continuous integration / continuous delivery, or CI/CD processes. In your Azure Synapse workspace, in the Azure portal, launch Synapse Studio. Synapse Studio is divided into activity hubs. These hubs enable you to see quick access items in the overview, storage accounts in the data, write code in the develop, supervise resources in the monitor, configure pools in the manage, and set up pipelines in the orchestrate hubs. The overview hub allows you to quickly access common gestures, see recently used items, start coding, and view links to tutorials and documentation. Within the Overview Hub, you can also quickly begin a new SQL script, notebook, data flow, Spark job definition, Power BI report, pipeline, or import. Moving down the left side bar menu, we find the Data Hub. After selecting the Data Hub, expand the Storage Accounts option to view the storage accounts in the workspace. After selecting a storage account, you can create new folders and upload files using the links in the right-hand window. Expand the storage accounts options to view the storage accounts in the workspace. After selecting a storage account, you can create new folders and update files using the links in the right-hand window. Select the container, in this case file system, and choose a specific file. You can then right-click and select Preview to sample the data. You will then see sample data from the file you chose in the right-hand window. You can manage fine-grained access and configure the access control lists by right-clicking on your files or folders and then selecting Manage. From here, you can manage the users and groups within Azure Synapse. From within the Data Hub, you have simple actions that allow you to auto-generate SQL scripts or open a new notebook with just a right click. Synapse allows you to bring together your data lake, data warehouse, and big data analytics all in the same hub. Next, we're going to talk about the Develop Hub. With the Develop Hub, you can start coding faster and use the language of your choice. From within this hub, you can author SQL scripts, execute SQL scripts on either a provisioned SQL pool or a serverless, or publish individual SQL scripts or multiple scripts through the Publish All feature. If you are used to SQL Management Studio, you will have the familiar feature of IntelliSense. View query results with one click directly within the Developer Hub. Just click Preview. Within this feature, you can see a sample of the raw data, or you can choose to chart it. You can also export these results to CSV, Excel, JSON, or XML files for more data exploration. You can go from writing SQL scripts and back to your data flows with one click. Data flows are a visual way of specifying how to transform your data. Take advantage of the code-free experience without even having to leave a different ETL tool. Bring in your Power BI workspace within minutes by adding it as a linked service. It is as simple as selecting the icon, putting in the workspace information, and now you're going from data ingestion to data visualizations in one analytics platform. Within this hub, you can create Power BI reports, provide access to published reports in the workspace, update reports in real time from Synapse, and show on the Power BI service and visually explore and analyze your data. Synapse is not only fast, but it is fast and inexpensive. GigaOM recently benchmarked all the top cloud data warehouse providers and found that for every unit of performance, Synapse customers pay 75 cents compared to $1 for Amazon Redshift and 6 cents compared to $1 for BigQuery. Extending the data point from the last time, this graph clearly shows that Azure Synapse Analytics leads at any level of compute. Microsoft continues their leadership in the analytics space, as seen in the TCP/DS results published by GigaOM in April 2019. Azure Synapse deeply integrates with Power BI and Azure Machine Learning to drive insights for all users, from data scientists coding with statistics to business users using Power BI. And to make all types of analytics possible, we're announcing native and built-in prediction support, as well as runtime level improvements to how Azure Synapse handles streaming data, Parquet files, and Polybase. Let's dive into a little more detail. With the native predict statement, you can score machine learning models within your data warehouse, avoiding the need for large and complex data movement. The predict function, which is currently available in preview, relies on open model framework and takes user data as input to generate predictions. Users can convert existing models trained in Azure Machine Learning, Apache Spark, TensorFlow, PySpark, or other frameworks into an internal format representation without having to start from scratch, accelerating time to insight. Microsoft has enabled direct streaming ingestion support and the ability to execute analytical queries over streaming data. Capabilities such as joins across multiple streaming inputs, aggregations within one or more streaming inputs, transformation of semi-structured data and multiple temporal windows are all supported directly in your data warehousing environment. For streaming ingestion, customers can integrate with event hubs, including event hubs for Kafka and IoT hubs. Native SQL streaming allows high throughput ingestion, data latencies in seconds, scalable throughput, and analytics capabilities. Concurrency is an important ask for many of Microsoft's customers. In a nutshell, it indicates the number of simultaneous users or queries that can be run at the same time. Azure Synapse Analytics leads the industry in concurrency with up to 128 concurrent queries for a single data warehouse. Concurrency increased with an increase in compute power, adds more compute power would let more users to access the data. Adding more compute power. There are preset functions called resource classes that users can leverage to set concurrency limits, thereby diverting resources to more important workloads. Workload management helps you control and prioritize your workloads. Use this feature to have granular control on how your workloads are being run, or how you allocate resources to different users based on the importance of their queries. Materialized views give you a new level of insight by adding transactional consistency to data modification and automatic query optimizer matching. Materialized views in Synapse SQL Pool provide a low maintenance method for complex analytical queries to get fast performance without any query change. A materialized view persists the data returned from the view definition query and automatically gets updated as data changes in the underlying tables. It improves the performance of complex queries, typically queries with joins and aggregations, while offering simple maintenance operations. With its execution plan auto-matching capability, a materialized view does not have to be referenced in the query for the optimizer to consider the view for substitution. This capability allows data engineers to implement materialized views as a mechanism for improving query response time without having to change queries. A materialized view in Azure Data Warehouse is similar to an index view in SQL Server. It shares almost the same restrictions as index views, except that a materialized view supports aggregate functions. When result set caching is enabled, Azure Synapse automatically caches the query results in the user database for repetitive use. This allows subsequent query executions to get results directly from the persisted cache, so recomputation is not needed. Result set caching improves query performance and reduces compute resource usage. In addition, queries using cached results set do not use any concurrency slots and thus do not count against the concurrency limits. For security, users can only access the cached results if they have the same data across permissions as the users creating the cached results. We have multiple levels of security between the user and the data warehouse in Azure Synapse. This keeps your data safe and secure. While some of our competition charges for different levels of security, Microsoft doesn't. Microsoft offers one comprehensive security plan, all at no additional cost. Let's dive a bit deeper into some of these features and see how they keep your data safe and secure. With threat protection, You get notified of potential threats with auditing tools and anomalous activity alerting. You can leverage network security to ensure that all the data is within the secure environment. You're able to centrally manage and control identity and user access with Azure Active Directory. There's row and column level security that provides granular access control. And your data is protected at rest, in transit, and in use. So one example of this in this particular comprehensive security has to do with access control. So with access control, the combination of native row level and column level security, you can ensure that data is secure for each user. You have dynamic data masking that enables administrators and data developers to control access to their company's data, allowing sensitive data to be safe and restricted. It prevents unauthorized access to private data by obscuring the data on the fly. Because your data warehouse stores your most important and valuable business data, you should never compromise on security features. Azure Synapse Analytics is the industry leader in security. So an on-demand or serverless service offering is a service for answering business questions and is accessible only when you need them. The serverless option allows you to pay per query, and data is processed in your data lake storage account by Azure Synapse Analytics. A couple of typical serverless scenarios are discovery and exploration and data transformation. With discovery and exploration, you might want to just understand more about the composition of a data table or file. Some of the example questions are something like, what's in this file? How many rows are there? What is the maximum value? SQL Serverless reduces data lake exploration to a right click. The data transformation scenario allows for quick transformation of data and allows for simplification of the data pipelines. Serverless is a compute tier for single databases in Azure SQL database that automatically scales compute based on workload demand and bills for the amount of compute used per second. Serverless compute tier also automatically pauses databases during inactive periods when only storage is billed and automatically resumes databases when the activity returns. Serverless is a price performance optimized for single databases with intermittent, unpredictable usage patterns that can afford some delay in compute warm-up after idle usage periods. In contrast, the provision compute tier is price performance optimized for a single database or multiple databases in elastic pools with higher average usage that cannot afford any delay in compute warm-up. You can see many of the benefits listed here, including pay-as-you-go, multi-language support, and the use of T-SQL to query data, among others. Apache Spark is a parallel processing framework that supports in-memory processing to boost the performance of big data analytic applications. Apache Spark in Azure Synapse Analytics is one of Microsoft's implementations of Apache Spark in the cloud. Apache Spark includes many language features to support preparation and processing of large volumes of data so that it can be made more valuable and then consumed by other services within Synapse Analytics. This is enabled through multiple languages, such as C#, Scala, PySpark, and Spark SQL, and supplied libraries for processing and connectivity. Multiple languages are supported in one notebook by specifying the correct language magic command. You cannot reference data or variables directly across different languages in a Synapse Studio notebook. In Spark, a temporary table can be referenced across those languages. A Synapse notebook is a web interface for you to create files that contain live code, visualizations, and narrative text. Notebooks are a good place to validate ideas and use quick experiments to get insights from your data. Notebooks are also widely used in data preparation, data visualization, and machine learning. There are two ways to create a notebook. You can create a new notebook or import an existing notebook to an Azure Synapse workspace from the Object Explorer. Azure Synapse Studio notebooks can recognize standard Jupyter notebooks IPYNB files. All right, so let's talk about pipelines. Azure Synapse comes built in with the same data integration engine that you would experience in Azure Data Factory, allowing you to create rich, at-scale ETL pipelines without leaving Azure Synapse Analytics. You can ingest data from over 90 data sources. It also allows for pipeline logical grouping of activity. Code for ETL with the data flow activities is already built in. You can orchestrate notebooks, Spark jobs, stored procedures, as well as SQL scripts. It is a cloud-based data integration service that allows you to create data-driven workflows in the cloud for orchestrating and automating data movement and transformation. Mapping data flows are visually designed data transformations in Azure Data Factory. Data flows allow data engineers to develop data transformation logic without writing code. The resulting data flows are executed as activities within Azure Data Factory pipelines that use scaled out Apache Spark clusters. Data flow activities can be operationalized using existing Azure Data Factory scheduling, control, flow, and monitoring capabilities. Mapping data flows provides an entirely visual experience with no coding required. Your data flows run on ADF managed execution clusters, and Azure Data Factory handles all the code translation, path optimization, and execution of your jobs. Organizations need to do data preparation and wrangling for accurate analysis of complex data that continues to grow every day. Data preparation is required so that organizations can use data in various business processes and reduce the time to value. Wrangling data flows in Azure Data Factory allow you to do code-free data prep at cloud scale iteratively. Wrangling data flows integrate with Power Query Online and make Power Query M functions available for Data Factory users. Wrangling data flow translates M generated by Power Query Online mashup editor into Spark code for cloud scale execution. So here's a couple of use cases. For fast interactive data exploration and preparation, multiple data engineers and citizen data integrators can actively explore and prepare data sets at cloud scale. Next use case is code-free agile data preparation. Citizen data integrators spend more than 60% of their time looking for and preparing data. Allowing citizen data integrators to enrich, shape, and publish data in a scalable manner drastically improves productivity. The wrangling data flows allow citizen data integrators to fix errors quickly, standardize data, and produce high-quality data to support business decisions. And finally, data validation. With these tools, you can visually scan your data in a code-free manner to remove any outliers, anomalies, and conform it to shape the fast analytics. Data flows can handle all DML requirements, such as upserts, updates, and deletes in the SQL Sync. Table partitions enable you to divide your data into smaller groups of data. Partitioning is supported on all Synapse pool table types, including clustered column, store, clustered index, and heaps. The primary benefit of partitioning in Synapse SQL pool is to improve the efficiency and performance of loading data by use of partition deletion, switching, and merging. Data flows support flexible schemas that change from execution to execution so that you can build generic data transformation logic without the need to recompile your data flows. There are a variety of file handling capabilities available in Azure Synapse. For example, you can point to data located in Hadoop, Azure Storage Blob, or Azure Data Lake Storage. In the SQL pool, you can use an external table to query an Azure Blob Storage and Azure Data Lake Gen 2 with transact SQL statements, import and store data from Azure Blob Storage and Azure Data Lake into a SQL pool. For SQL on demand, you can use an external table to query data in Azure Blob Storage and Azure Data Lake Storage with T-SQL statements, and store SQL and on-demand query results to files in Azure Blob Storage or Azure Data Lake. There is a new inventory of functions available, from familiar looping and stored procedures to hash functions. Commonly used ETL patterns that we would use in tools such as SSIS or Informatica are now integrated in Synapse. When you run an automated ETL or ELT process, It's most efficient to load only the data that changed since the previous run. This is called an incremental load, as opposed to the full load that loads all of the data. It's also useful to record a lineage for each ELT run. For a given record, the lineage associates that record with the ELT run that produced the data. For each ETL run, a new lineage record is created for each table, showing the starting and ending load times. The lineage keys for each record are stored in the dimension and fact tables. So what you need to do as you're starting your journey, your data journey, is to ask yourself where you find yourself on this curve. And you need to take a step back and be honest about this. A lot of companies that we work with think that they are much higher up on the curve, and then once they look at this, they realize, oh, we're not quite as far as we thought we were. What we want to do here is look at the increase in value on the X and Y axis and determine what it's going to take to get there. BI is the beginning of the track, and you want to work towards maximizing the value of your data. And as we work towards understanding more and more business questions, such as why did things happen or why we can make certain things happen, this is where it is critical to bring BI and analytics together. Microsoft Azure is the only cloud analytics provider that brings the best of both worlds together in a single service. And both Power BI and Azure Synapse natively integrate with Azure Machine Learning. Give your developers a platform that is built for collaboration and driving more business value. Azure Synapse lies at the center of bringing all data professionals together so they can achieve more and accelerate the time to insight. A powerful analytics platform on Azure Synapse brings frictionless collaboration for business analysts using Power BI, data pros using Azure Synapse, and data scientists using Azure Machine Learning. Only with Azure can you provide insights for all across your entire organization in near real time. Power BI and Azure Data Services unlock big data in a way that would otherwise be impossible. As previously mentioned, it is not uncommon for companies today to have petabytes of data across the organization. Analyzing and extracting insights from such massive amounts of data used to take hours, if not days. Not so with Power BI and Azure Synapse Analytics. Using direct query, you can take advantage of Azure Synapse industry-leading performance right from Power BI without limits on concurrency. The new aggregations feature in Power BI boosts performance even further by caching data at the aggregated level, enabling instant response times on petabyte scale data sets with trillions of rows. If the user happens to drill down to the detailed level, Power BI will submit a direct query as usual, invoking Azure Synapse lightning fast query response. How fast? Up to 14 times faster than any other cloud provider. And it's up to 94% cheaper too, according to GigaOM. Together, Power BI and Azure Synapse gives users the performance they need to do modern analytics. According to Forrester report from October 2019, Azure Synapse provides an average of 271% ROI, 60% increased customer satisfaction, 27% faster time to insight, and 26% lower total cost of ownership. The last section here is going to talk a little bit about Power BI integration. BI is more than just reporting and dashboards. It enables interactive data exploration, self-service analytics, predictive analytics, and machine learning, as well as prescriptive analytics. The combination of Azure Synapse Analytics and Power BI opens exciting new possibilities for bridging the gap between massive volumes of unstructured and structured data and actionable insights. With the tight integration of Azure Synapse and Power BI, you will have the familiar Power BI workspace that allows for rapid creation of feature-rich visual reports and a performant and scalable data warehouse in one environment. In addition to be able to create reports from within Synapse, you'll also be able to have access to published reports in your workspace, and you can update and publish reports real-time from Synapse workspace and get it reflected in the Power BI workspace. Okay, I think at this point in time, we're going to have a bit of a break. Couple final finish up slides here. We are going to start into the hands-on lab. I think Jim's going to come on here and instruct you how to get started on this if you haven't already spun it up. Now is the time to spin up your lab. The final slide I would like to provide you here today is how can you get started with Azure Synapse. We would love to help you. We've been working on several projects right now with Synapse and with Azure Analytics in general. So you are more than welcome to email us directly. I would suggest though that if you email either of us directly, you also contact marketing as they show here under number 1, us-marketing@columbusglobal.com. You can also look at number 2 and 3 here. With number 2, you can start your free trial with Synapse, and there's a bunch of tutorials in there. And if you have any projects that you would like us to help you with or give an assessment on, big or small, you're having Power BI performance issues, something like that, all the way up to a larger scale data warehouse migration. We call it a lift and shift, from an older technology that's on-prem to a cloud-based technology that doesn't even necessarily have to use Synapse. We've been using a variety of architectures, but we would love to talk to you about that.